Hello, this is Lisa. In this video, we'll be discussing linear equations in two variables. We're going to start off with a definition, then I'll show you some examples of what we're talking about. The standard form of a linear equation in two variables is written as ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. In other words, you need an x term and or a y term in your equation. Some examples of linear equations. I do believe these are all in your workbook. We have 3x plus 2y equals 8. This one's nice. It fits exactly the format of the standard form. Now, x equal 10 is also an example of equation in standard form. We just don't have a y term. In other words, b is 0. Y equals -3 and 1/2 x minus y equals 3 are all examples of linear equations in standard form. Determine whether or not the given point is a solution of the equation. When we saw linear equations in one variable, we had just most of the time one number that worked as a solution. Here we have to have a point that is a solution. Points always have x coordinates followed by y coordinates, always in alphabetic order. So what they're asking us to do here is substitute -2 in for x. 2x means 2 times x, so this means 2 times, we're going to substitute in -2, plus 5 times, we're going to substitute 3 in for y. Is that equal to 11? I get -4 plus 8, plus 15. 5 times 3 is 15. I'm using my order of operations here, multiplying before I add. -4 plus 15, 11 is equal to 11. Yes, this is a solution. It works out perfectly when you plug the point -2, 3 into our equation. Let's look at a second example. Is 4, 1 a solution of the equation 3y plus x equals 8? Now be careful this time, the y comes first. It's 3 times. Our point, though, is always x comma y, so here y is 1, x is 4. Is 3 times 1, excuse me, is 3 times 1 plus 4 equal to 8? The answer here is no. 3 plus 4 is 7. 7 is not equal to 8, so our answer is no. That point is not a solution of the given equation. And let's look at our third example. Is 5, 0 a solution of 3x plus 5y equals 15? So if I plug 5 in for x and 0 in for y, 3 times 5 plus 5 times 0, is that 15? 15 plus 0, yes, that's equal to 15. It checks, so our answer here is yes. Now we're going to look at how do we actually complete ordered pairs. So when we're given an equation in two variables, if we start off with the value of one of our variables, in this example, they're telling us x is 10 and they're asking us to find the y value, we're going to substitute 10 into our equation for x. So our equation becomes 10 minus y equals 6. Using my equation solving skills, I'm going to move 10 to the other side by subtracting it, once on the left and once on the right, and I get minus y equals -4. Divide both sides by -1, and we get y equals 4. So my completed point is the point 10, 4. Let's do another example. We have the same equation here, except this time they've given us a y value to start with. If I do x minus, I'm going to substitute 7 in for y, equals 6. Here to solve, I need to add 7 to both sides so that I get x by itself, and I have that x equals 13. So my answer here would be the point 13 comma 7, final answer. Let's look at the third example. Again, we're using the same equation here. This time we're given an x value of 0. So we have 0 minus y equals 6, or just negative y equals 6. Divide both sides by negative 1, and we get y equals negative 6. So our answer is the point 0 comma negative 6. Now, when you're graphing a linear equation in two variables, such as x minus y equals 6, if you were to plot all of these points on a grid, they would give you a straight line, hence the name linear. Now, completing the table of values is primarily the same as what we were just doing. We're either going to start off with an x value or a y value, substitute into the equation, and solve for the missing value. When we're given a chart like this, this tells us we're looking for 1, 2, 3, 4 points. So for number 1, if I start off with x equals 0, right, that's what they've given us here is x equals 0, and we're trying to find that missing y value. So calculation number 1 is 1/2 times 0 plus 2y equals 4. Using my equation right here, all I did was substitute 0 in for x. So I get 2y equals 4. Divide both sides by 2, and I get y equals 2. So to complete my table, I can plug 2 into my table. Calculation number 2. What are we starting with this time? This time we're starting with a y equals 0. If I plug y equals 0 into my equation, I get 1/2 x plus 2 times 0 equals 4, or 1/2 x equals 4. And to get x by itself, I'm going to multiply both sides of my equation by 2. And I get that x equals 8. So I complete my table by putting an 8 in for x. Calculation number 3. X equals 2 is what we're given in our table here. So we want 1/2 times 2 plus 2y equals 4. Half of 2 is 1 plus 2y equals 4. Subtract 1 from both sides, and we get 2y equals 3. To get y by itself, we divide by 2, and we get y equals 3/2. Notice, not all of our values are going to be nice, neat integer values. Sometimes we will have fractions as our answers. And number 4, I'd like you guys to pause the video and try to see if you can find that last value in our table. So pause now. And the answer that you will get here, half of x plus 2 times 4 equals 4, or 1/2 x plus 8 equals 4. I need to subtract 8 from both sides. So I get 1/2 x equals negative 4. And if I multiply both sides by 2, I get x equals negative 8. So my final answer here should be negative 8. Okay, and these definitions are in your book. They say definition number 1, the point where the graph crosses the x-axis is called the x-intercept. When we look at an x-intercept, we'll notice that the y-coordinate will always be 0 at the x-intercept. Okay, so our y value is always 0. We have a number for x. It could be 0, 0, but oftentimes it's a number other than 0, but the y coordinate is always 0. And the point where the graph crosses the y-axis is called the y-intercept. The x-coordinate will always be 0 at the y-intercept. I'm going to look at some examples now where we complete tables of values for equations, and we're going to identify the x and the y-intercept when we do that. Complete the table of values. Again, if you would like to pause the video and do this work on your own, you may. I'm going to work through it fairly quickly since we've already done an example. In the charts, we have to do 4 calculations to fill in this chart. The first one, when x is 0, we get 3 times 0 plus 2y equals 12. This cancels out, it's just 0. If I divide 2y by 2 and 12 by 2, I get y equals 6. In line number 2, we have y equals 0, so 3x plus 2 times 0 equals 12. That goes away. 2 times 0 is 0. And to get x by itself, I divide both sides by 3, and I get x equals 4. In line 3, we're starting off with x is 2, so 3 times 2 plus 2y equals 12. 3 times 2 is 6. If I subtract 6 from both sides of my equation, I get 2y equals 6. To get y by itself, divide both sides by 2, and we get y equals 3. 3 is the last line in our equation. Sorry, this is the third line. And to do the last line, we're going to plug 3 in for y. So 3x plus 2 times 3 equals 12. 2 times 3 is 6, so if I subtract 6 from both sides, I have 3x equals 6. Divide both sides by 3, and we wind up with x equals 2, and we can fill in that last line in our table. Now, notice, we have 2 points with a 0 coordinate. In the first line, we have 0, 6. The point 0, 6, that is our y-intercept. In the second line, we have 4, 0. 4, 0. This is going to be our x-intercept. Let's do our second example. Example number 2 is one of our special kinds of lines. We only have one variable in our equation. So the only thing that this equation tells us is that x has to be -3. So when I look at my table, I know x has to be -3. I have to plug -3 in for all of my x values. In this special kind of line, it's a vertical line. We are only going to have one intercept. We are only going to have, whoops, pen went crazy there. We're only going to have an x-intercept for this particular kind of graph. And now let's look at example 3. Example 3 says we have y minus 2 equals 0. When you only have one variable, you want to solve for that variable. So we want to solve for y in this case. I'm going to add 2 to both sides, and I get y equals 2. So what that equation tells me is that in my chart, all of my y values must be 2. Y has to be 2. So 2, 2, 2. Doesn't matter what my x values are, the equation tells me what y has to be. And again, this special kind of line, we only have one intercept. This time, though, we're going to have a y-intercept. And that concludes the video for section 5.1. Again, this was Lisa. Nice to have you in class. You are ready to do section 5.1 homework, followed by the quiz.